Hello, everybody. I am David Karam. I'm the product manager for Chrome and Android in the enterprise. And I work very, very closely with our engineering team to bring you all these features that you know and love about Chrome OS and Android. What I want to do today is talk to you about security within Chrome OS. Chromebooks have a very strong reputation in the market for being a very, very secure endpoint, actually one of the most secure endpoints on the market. And many people know that, and it's a reputation in the market. But do we know actually concretely what makes Chrome OS more secure than other platforms? And what I want to do today is actually take you through a guide of all these features and improvements we've made to the platform to actually make it as secure as it is today. And one overarching message in that tour is going to be that across the platform, security is actually built in. We don't, it's not something we do in parallel. It's not like one feature, which is a super secret sauce of the platform. It's actually something we built into the platform and across the entire stack. So if you look at the device, what constitutes a device, right? It's the hardware, the firmware, the operating system, up to the management layer and user sessions, all the way up to the Play Store and the browser and how apps are delivered to the platform. And the thing to keep in mind is actually we bake in security at every single layer in that stack. It's not one or two, it's every single layer. And every time we add a feature to the platform, we make a full security review and we try to bake it really inside. And this gives us a really, really good edge. And as I'm going to describe for each of these features, they all interact together to produce an experience that is really, really secure and makes the endpoint very, very secure. So what I'm going to do now is take you through every single layer and kind of describe a little bit around the security stature and the security features that exist in that layer. Right? So let's start on the hardware layer. What we know is that every Chrome device on the market today has a TPM. A TPM is a trusted platform module, and it's a security chip that lives within the Chrome device. And this is very, very important to know, right? Because a trusted platform is, in effect, it acts like it's a very secure chip, and it acts like a smart card on your device. So which means that every time you buy a Chrome device, there's a built-in smart card. And this is very, very important to know because, as we will see later, this security chip is used in many, many other features that build the security on the upper layers. And what I want to really only mention here is that we don't sacrifice with that, right? Every single Chrome device has this trusted platform, has this security chip. And even though it would, enable us to produce lower cost hardware by removing this, we actually do not do that. We do not sacrifice this on security in this. And this is very important on the hardware level because it builds on a lot of things that go on top of it. If we go above the hardware, now we look at the firmware. We have something called verified boot, which is one of those main pillars of security for the platform. I'm going to try and describe it very briefly here. What you see in these diagrams on the left and on the right is that on Chrome OS, the boot process starts from the firmware. And on the firmware, there's this read-only partition. This means it's a piece of code that no one can change, not an attacker, not Google with its own update infrastructure. No one can change that, and it's purely read-only. And what happens in the boot process is we start with this read-only portion of the code and start executing other pieces of code that built on top of that. And while we execute that code, we check for the signature. And all these signatures chain back to this read-only partition that cannot be changed. This allows us to ensure that all the code that is being executed is code that we know about and code that we can verify the integrity of. And this is demonstrated by the diagram on the right-hand side, right? Because if an attacker actually manages to inject malware and change this code execution routine to have persistent malware on the system, the Chrome device will not boot, right? So it will start with the firmware and then try to execute those code pieces and check their signatures. But then it will hit the malware and will think, oh, well, this is code I have never seen before. So this was not what I know to be a proper Chrome OS image. And we'll stop the boot process and then reboot back to something that is clean. And this really raises the bar for persistent attacks, right? Because you cannot bring a piece of code and have it execute within the boot process or just afterwards without triggering these protections within the Chrome device, which causes it to boot back into a clean image. Right. Above the firmware, and once now we're past the verified boot layer, well, we have the operating system. And on the operating system, this is a very massive surface, right? On the operating system, you have services like the networking layer. You have services like which deal with the GPU, which deal with bringing up the user sessions. All these services have a very vast attack surface. And what we need to make sure here is that if any of these services is compromised, they cannot infect other services, right? And this is what we talk about, like with process sandboxing. All these services interact with each other through very well-defined interfaces, so that if one of them is compromised, it cannot compromise other services. And with privilege separation, it's a very, very close concept as well. A lot of these services do not need wide privileges. So if you look at something like the networking layer, it doesn't need access to things like the camera or the GPU, right? So Chrome OS really locks down and says, well, you're the networking piece, so you will not give you access to the GPU or to the camera. So that if there's an exploit that happens in the network piece, then that exploit cannot spread or cannot give this attacker too much privileges, right? So, and again, like this is not a feature that's on its own will protect the system, but this feature in combination with many other features significantly raises the bar for any attacker to do strange things on the platform and to persist attacks that go beyond that. Another feature is full disk encryption. And this is something that is not something that needs to be turned on, right? On many other platforms, you have your hard disk, and then it's a feature where you can enable it, and now it protects it encrypts your hard drive. On Chrome OS, this is not. This is just the default. All data that is stored, whether it's user session data or system data, is encrypted on the device at rest. So when the Chromebook is turned off, it's actually not accessible. The data on the device is not accessible to attackers from the outside. And the fourth point that we want to talk about is automatic and seamless updates. And this is really a cornerstone of security, because once an exploit is actually found, and no system is prone to exploits, right? Every system is prone to exploits. And what we really want to make sure that if an exploit is actually found, then we can actually issue a patch and update devices in the field. And this is very, very important, right? Because we can patch them, we can issue a patch, and we can send it to all devices in the field in a very, very short time, typically in the order of 24 and 48 hours. And this is something that does not exist on other platforms, the ability to issue patches and update devices in the field in such a quick and easy manner. And this protects the system against vulnerabilities that have been found but have been patched, and allows all the users to stay up to date and all the devices to stay up to date. And another feature of this is that this is really seamless, right? So this is not a device that, oh, I got an update, so now I have to, restart the computer and wait 3 seconds for it to apply the update, 3 minutes to apply the update. On Chrome OS, this is very, very seamless. So you have the update is downloaded and placed next to the other system image. And then on boot, we still boot up in 6 seconds, because the only thing we do is we swap to the new image, right? So the user doesn't have to feel of that, right? So update stops being a pain, it's automatic. And then all users just get it and apply it without having to wait or become out of date. On top of operating systems, we have user sessions. And on Chrome OS, it's a device where multiple users can share the device. And this has been very, very successful in many, many different use cases. One of the most prominent of them is actually the education use case, right? Where you have a card that comes into the school, into the classroom, and then students just take any device and just log in, and they have all their apps and data. But it's actually very hard to protect users against each other, right? Because now you have multiple users and you have multiple user data. So here comes our first feature, which is per user encryption. Every single user has their data within their own partition, and that partition is actually encrypted with a hash of their password. So that if you have another user that actually is compromised, it will not infect other users on the system. So here again, we raise the bar significantly so that a compromise that happens in one place cannot spread to another place. And in this case, it's a compromise for user A does not spread to user B, because user B's data is actually encrypted with user B's password. And even a compromise within user A cannot reach into that data. So we significantly raise the bar there. Another one within user session is, again, process sandboxing and defense in depth, the things we mentioned on the operating system level. But we also take it to the user sessions, because we know within user sessions you have a lot of apps that run. So take an example like the Chrome browser, which has a render that displays the web pages for the user. So now suppose an attacker actually finds an exploit and wants to exploit the render to get to that user data. Actually, Chrome is treated as an untrusted application within Chrome OS. And an exploit within Chrome cannot leak into Chrome OS, right? So if you exploit the browser, you will not be able to leak that exploit into, for example, the network layer, right? Because these are sandboxed, and they talk to each other within very defined interfaces. Another feature is cross-device policy compliance. And this is important to note because what enterprises and schools generally want to do is that policies actually follow users around. So I'm a user and I log into Chromebook A versus Chromebook B. It's very important from an administration perspective, from a security perspective, that my policies actually follow me around. And this is something that we have implemented in Chrome OS, so that you as a user, whether you're logged into one device or the other, it doesn't matter, your policies follow you around. So if I've set a certain set of policies for user A, if that user logs into one Chromebook or the other, to their personal Chromebook or into their enterprise-enrolled Chromebook, it doesn't matter, they will get a managed session. And this is very important from a security perspective, because many times those managed policies imply things like, I want to enable your lock screen, or I want to monitor the network traffic that is happening. And this follows the user around as they go from device to device. There are also other features that we inherit from Chrome browsers, such as safe browsing, which is Chrome knows that there's a lot of malicious websites out there, and we do a lot of analysis on our servers of websites that we know to host malware, or websites that we know that will exploit the users. So we generally block users from going to those websites, right? And admins can enable that feature for their users so that they know they can browse safely on the internet, and they won't be taken through clickbait and through other measures into websites that will eventually install malware on their system. Certificate enrollment, again, is one of those things where you can use the TPM on the device, the security chip, to actually generate keys that allow you to enroll for a certificate with a packet. And this is very important, right? Because as we mentioned, every Chrome device has a TPM. So you have a guarantee when you're on Chrome device that you can have your entire fleet and all your users using hardware-backed certificates, which have much stronger security stature than software-backed certificates that can be copied around and taken from user to user and from machine to machine. If we go even on a higher level, right, you look at like policy and management, right? So what we have on Chrome OS is something that's also a big focus for us. How do you actually achieve security when you're looking at that layer? And we have many actually concrete features that we've added over time. One of them is permission controls. An admin might say, well, I would like actually to have a stronger security posture when it comes to audio and video, where I do not want my users to be allowed to use video, right? And you can actually enforce that on a Chrome device so that you can block the users from accessing apps that actually use their video, in case some malware now decides to spy on users through their cameras. If you look at the networking layer, we also have policies there that allow you, for example, to restrict the Chrome device from connecting to any network that is not a managed network, right? So when you come to work, you can actually connect your network to your Chromebook to the internet. But if you take your Chromebook and try to go to a Starbucks cafe, then, or to like a regular internet cafeteria, then you will not be able to connect to the internet. Proxies is another one of those policies where you can force a user and a device into a certain proxy so that you can monitor all the traffic that is going through the session. And of course, we have many other policies that can be enabled, sign-in restrictions, where you can define which users can use a device, and things like signed policy delivery, where any policy that actually comes onto the device is signed by the Google servers, so that you know that attacks like, for example, injecting policy via man-in-the-middle attack is not possible, because we will always verify the signature before applying the policy, and that makes the policy completely unspoofable, right? Let's take it even a level further. So once you are on the device, you have booted your operating system, you are within a user session, and it is a managed user session. And as we mentioned, we have all these mitigations in place to actually make sure that this is a secure endpoint. And we take it to the next level, which is app delivery. So I go to something like the Play Store. How can I verify that the apps I'm getting from the Play Store are actually good apps, that this is not malware? How can we actually protect the user in these situations? And this is where we also have a lot of protections in place. So for the Play Store, for example, we have a massive infrastructure that actually checks each and every app that is uploaded for any signs of malware, right? And we have, this is all based on Google's machine learning algorithms, and it's becoming better and better and better with time. And this is a way where we marry the technologies, we marry client-side and server-side technologies to protect the users, so that even when the users are not actively on their machines, we're still doing a lot of stuff on the back end that ends up increasing the level of protection for users on their devices. Another thing that is possible is to remotely uninstall apps from users' systems. So if we, after users have installed apps that have been, and then they have been detected by Google to be malware, can issue an uninstall command, and these can remove all these apps from users' machines. And this is, again, this is very unique to the Play Store and to Google's platforms, right? And it is one of those security features that differentiate it from other platforms. For administrators, there's also many different ways to block users from using certain apps, right? So you can actually configure a Chrome device and the Play Store on the Chrome device to not allow the installation of any app except those within a certain whitelist. And this is a posture that many enterprises like, right? Because they can control exactly what users can install. So in a way, they limit the ability of users and the flexibility to use the platform. But then again, it increases their security posture because they know they have certainty around which apps can be installed. And because we don't allow side-loaded apps on Chrome devices, now they have a very good certainty that what they decide to be in the whitelist is actually what is being installed. One last thing we want to describe, and this is a feature that has been added recently, and where a lot of you heard about it and wanted to hear more about this, is verified access. Verified access is actually very interesting, and it goes beyond a lot of the things it builds on top of a lot of the things we are doing. And I'll try to describe it here. What it basically gives you is a real-time check on the integrity of your system, right? So in real time, you can tell whether a Chromebook is actually a Chromebook that has been booted into verified mode and is enterprise enrolled. And this is a very, very strong check because it's a cryptographic check based on the TPM. And on many different platforms, you can make similar checks, but they're all heuristics based. So they're trying to figure from the client whether it's compromised or not. But we know that this is not enough because a compromised client can always spoof these signals. So if you have a virus on the system and you ask the system, hey, are you in a good state? Well, the virus has already compromised the system and it can spoof that signal. It's like, yes, I am in a good state. Carry on, right? Give me your valuable resources, download your email, give me access to your network. And this is something we want to avoid. So what happens today on a Chrome device is the following. You can actually set up a network service so that it can know whether it's talking to a genuine and Chromebook that's been booted in verified mode. And the way it does is, first of all, you want the Chrome device goes to the Google Verified Access Server, and it asks for a challenge. It gives it back that challenge, and what it does on the device, it uses the TPM to go in and produce a response for that challenge. And that response for the challenge is bound to that challenge, and it verifies that this device is actually in verified mode. Now, it sends this challenge response to the network service. Network service generally is responsible for protecting the certain resource. So for example, imagine a network service that gives you access to certificate. So you're trying to mint a certificate for your device. Now, before you give that certificate back to the device, you take that challenge response and verify with the Google Server API again. Well, here's the challenge response I received from a Chrome device. Is this a valid Chrome device? And this is a real-time integrity check because the Google service can now actually tell the network service that's trying to give a certificate or trying to give you a bunch of emails, and tell you, yes, this is actually a Chromebook that has booted in verified mode and is enterprise enrolled. So you have this real-time check of the endpoint integrity. And then the network service can decide, well, now that I can trust this endpoint, I'm going to give it a certificate. I'm going to give it its emails. And this is very, very secure and very cryptographic. And it's really a very, very strong check regarding the integrity of the endpoint. So this concludes our tour of all the different layers. And as we have seen, this security is not one thing or one feature on a certain layer. It's actually something that we spread across many, many different layers in the operating system. And this goes all the way from the hardware to the firmware to the operating system to user sessions, through policy and management, app delivery via the Play Store, and verified access, which is the feature we mentioned last. Now, would love to hear your comments on this, and of course, if you have any questions, please send us these questions, and we will try to answer them as well as possible. I really hope you have enjoyed this tour, and looking forward to all your questions. Many thanks.